Okay, good morning, students. Let us start with the lecture. So, sorry for the late. Still, many of the students had not joined, but still, we will join. Still, will start. So, we started with the third chapter in the syllabus, that is mathematical foundations, and within that, we have seen about linear algebra, where we have seen what is meant by a vector, what is meant by a matrices, for which purpose these can be used, and how these can be represented by using a Python language. And then we have seen the statistics. So statistics, it means that this is giving information about my existing data values. So here we have seen how we can describe a single set of data, just like even though I'm having hundreds of records or thousands of records. In order to describe that data, I cannot go for representing every single values or remembering those values and citing those values. So here we are describing that data in terms of just like statistics. So statistics, it means that this is a way how we represent our data. So statistics can be any conclusion. For example, average values, average mean values, median values, smallest values, largest values, etc. Again, we have seen the concept of quantile and mode as well. So this is how we are representing our single set of data. Then next we have seen the correlation. Correlation, it means that here, if I'm talking about two values of a data that is considered, that is we are having data of cells or data of some uh, products, etc. So correlation, it means that when I am talking about X and Y attributes within my data or X and Y values in my data. So as per X, if my Y is changing, then we can say that there is a correlation between these two values. So it might happen that because of Y, X is also changing. So here correlation, it means that there is a relation between the values set and which is applicable for the every value set whatever we are learning. For example, I cannot say that if as per the X, if my Y is changing for the only two data members or two rows or two records, then I cannot say that that is a correlated. No, here correlation, it means that if I'm able to give a mathematical relation between X and Y, then we can say that there is a correlation existing between these two attributes. Next, we have seen the Simpson's paradox. So this is exactly reverse of the predictions whenever we are subgrouping the elements. So here, consider that Simpson paradox, it means that consider that I'm in a group. I'm talking about the 100 object and there I make some conclusions that this is having the highest rate or this is having the highest sale, etc. So here consider that I'm talking about one or two factors or two features of my data. And if consider we applied any third parameter or applied any third attribute and try to analyze the things, then if we consider when it comes to the subgrouping by adding the third factor into the existing, if our conclusion get reversed, then that phenomena is called as the Simpson's paradox. So Simpson's paradox, it means that whenever we are making some facts or stating some facts or statistics in group will be get reversed when it is divided into subgroups. Okay. And then correlation and causalizations. Correlation and causalizations, it means that correlation, the just like whatever correlation we have seen. So if consider based on X, if my Y is changing, then we can say that there is a correlation between these two elements. But when it comes to the causalizations, it means that there is a cause that because of X existence of Y is there. Because X is acting as a rule and from that X is Y is generating, or cause and effect because of X, Y parameter is there. Then we can say that that is a causation. So here we can make a conclusion that correlation always doesn't mean that causalizations. Yes, causalizations always mean a correlation, but correlation always doesn't result into causalizations. There might be some elements which are mathematically related, but it doesn't mean that because of one parameter existence of another parameter is there as a effect of or cause of one action to another. So this is the difference between causalizations and correlation. Next, we started with the next concept, that is the probability. probability, so this here we are predicting some kind of values, so which will be used for the future predictions or guessing of some values, and because of which we may go for taking the risk or taking some other corrective actions, etc. So probability, it means that occurrence of an event, that is possibility of occurrence of event, we can say that is a probability. Next, within that we have seen the concept of dependence and independence. So dependency means that if I'm talking about two events or two probabilities, consider E event is there and F event is there. So if consider event E occurred and F event yet to occur, then in that case, if E can give information about event F, then we can say that there is a dependency between these two events. That is, F is dependent on the E. Okay. For example, I'm having two events E, that is considered coin tossing. Sorry, tossing the coin, tossing the coin. Then in that case, if consider the coin is having two possibilities, that is head and tail. So if consider the E event is that the first toss will get the head. Okay. And F event is that if we toss coin for the twice, then possibility of double head. That is both the times head is there. Okay. So that is the F. Then in that case, we can say that here E event occurred, this will definitely give information that whether F is going to occur or not. Okay. If consider during the E, I get the tail. Okay. Then I can say that F event will not occur. Okay. Or there is a zero possibility of occurrence of the F. Then it means that here F event is dependent on the E. So that is a dependence. And if consider E occurred as head, then I can say that here possibility of having occurring the F event can be 50%. That is, in the second toss, it might be tail or it might be head. So it means that there is a possibility, it will give the possibility that is F event will occur or not. Okay. Then next, independence, it means that here independence is that if E and F events are there, that there is no dependency between them. E doesn't give any information whether F will occur or not. Okay. So in that case, consider that my F event is second should be a tail. Okay. Second toss is a tail. If that is the case, then E event will not have any effect on the F. Then we can say that these two events are independent. So we have seen the possibility formulas for both of these. Then next we started with the conditional probability. Conditional probability, just like dependence and independence, is a conditional probability. It means that F event will occur based on the E. Okay. So, and next we have seen the Bayes theorem, and we started with the random variables. Okay. Bayes theorem, let me go to the definition. If any of the student is having a doubt. Okay, conditional probability, the event, is the probability of an event occurring provided another event has already occurred. The formula is this, that is based on the A. But if B is happening, then we can say that is a conditional probability. Then next, here we have seen the example of students, that is if there are two tests, how many students will get passed into the examination. That is, we have taken the two test example. In the two test, if consider, I've taken within that, if in the first test, if these many students are getting passed, then how many students will get passed into the second test? So it means here we have seen the dependency. Next, we have seen that is a Bayes theorem. That is here we are going for probability of hypothesis based on the various data. So here in case of Bayes theorem, here we are reversing the conditional probabilities. Reversing it means that here we have seen the example of here positive. This is positive, that is HIV positive cases we have seen. So here we have seen how even though if consider there is a possibility of a test that it will give the 99% the accurate results of positive people as well as 99% of negative people. That is, it means that if I taken the test of 100 candidates, or consider that I've taken a case of consider few people, and within that, if 100 people got positive, that is HIV positive, then there is a 99% possibility that if test is positive, being a HIV positive is 99% chances are there. Okay. And if consider the 100 people are having the negative test, then there are 99% chances that the person is HIV negative. But overall population is having a 0.3 percentage of HIV positive. So it means here based on the test, we can guess how many people will get positive at a time. Then we studied this formula, that is it is reversing the results. That is here we are checking for the probability of testing positive HIV positive as well as probability of HIV negative. Okay, and then we started with the random variables. So if you are having a doubt in the previous points, let me know. I will wait for a minute. Let me know if any of the concept you want me to repeat. If so, I will repeat. Else, we will start with the remaining points. And I hope to complete this chapter today. So let us see. Please go through the syllabus. We have seen up to Bayes theorem, random variables. We yet to start. Okay. I hope I'm still in the meet. Okay. A random variable is a variable whose possible values have an associated probability distribution. Okay, so here associated probability distribution, it means that any increase in the value or uh, getting the some constant value, etc. Okay, so a very simple example, consider that there is a random value equals 1 if coin flips turn up heads and 0 if consider flip turns up tails. Okay, it means that if I'm flipping the coin, if it is head, I will have one value, and if it is tail, then I will have a zero value. Okay, so if consider we are going for consecutive, that is a flipping coin for 10 times. Okay, then here in order to represent this value, that is how many flips I got head and how many flips I got tail, that we wanted to represent. So within that, I can say that my value will lie within 0 to 10. Sorry, 0 to 10. Yes, because I may get 0 number of the heads or I may get 10 number of the heads. Okay. So it means that initially whenever we are talking about one or twice flipping the coin, then it is easy. But when it comes to the multiple flips of the coin, then here we might have range of more values, that is from 0 to 10, where each number is, it means after first flip I cannot guess that what will be the second number. It means here each number is having the equal weightage. So this associated distribution gives probabilities that variable realizes each of the possible values. Okay, so it means that how much value will be there, that is its own, that is each flip is having its own equal distribution. So the flip coin variable equals 0 with probability 0.5 and 1 with the probability 0.5, that is possibility of having tail and head are respectively. So if consider the range 10 variable, that is 10 will be the max value, has distribution that assigns probability 0.1. Okay, then you might be thinking why this is there. That is how we can say that the possibility probability is 0.1 to each of the numbers from 0 to 10. Here, if consider okay, here I'm having range from 0 to 10. Okay, minimum this much value can be there and max this much value can be there. So if I'm saying that these many values can be there, that is 0 or 10 can be there, we can say that each one is having the equal probability. That is, I may get 0, I may get 1, I may get 2, 3, 4, etc. So here each of this will have, wait a minute. So each of this probability will be having 0.1, that equally 10 numbers are there, then I will have each of this will probability 0.1. Okay, then next, so consider that sometimes it means which will average the value weighted by their probabilities. So we will sometimes talk about expected value of random variable, which is average of its values weighted by their probabilities. So the coin flip variable has expected value of 1 by 2, that is 0.0 multiplied by 1 by 2 and 1.2. And here the range is 10. So variable has expected value of 4.5. So it means that here, whenever we are talking about this, that is, consider that if consider we are talking about 10 numbers, that is one is having probability, then it means consider that this is my first flip. Okay, in the first flip, I can say that 0 coming the 0 can have probability 1 by 2, that is a tail, and having 1 is also probability 10, sorry, 1 by 2. 1 by 2, it means that this first flip I will get 10, that is 0 value, that is probability is 1 by 2 and this is 1 by 2. So if consider I wanted to perform the summation of all these, then we can say that in each of the cases, okay, in if I'm talking about the 10 probabilities, then here 0 to 9 or 10 will be the values. So having 1, this will have probability 1 by 2, plus having 2, this will have probability of 1 by 2. Similarly, it means again they here 1, 2, 3, 4, 5 up to 9 to 10 are there. So it means that 1 by 2, this will be taken for the uh, this will be taken for the 10 times, that is 10 flips are there, and because of which 1 by 2 multiplied by 10. So sorry, no, yes, multiplied by 10, because we are having these 10 probability will be equal to 5. But why this is showing 4.5? Okay, here it has considered a 9 value. No, actually it should be 5 only. Okay, that is 10 probabilities. Each one is having its own. That's why this will have probability, that is expected value, average value will be 5. Okay, so this is regarding the conditional, random variables. So then next, let us start with the continuous distribution. So before moving to the continuous distribution, so let me tell you. So regarding this one, that is the previous cases. So whenever we are talking about 0 or 1 values, etc., it is always a discontinuous values. That is, or discrete values we can say. Discrete, it means that here just like we are having the sine wave or cosine wave, that is with each fractional value I can have a fixed value for the that attribute. So similarly, which is a continuous range. So but when it comes to the flips or when it comes to the such cases, then we can say that these are the discrete value. So or discrete model we can say. So now we are talking about the continuous distribution. Continuous distribution, it means that here throughout the range we are having the specific values. So let us go through this. So often we will want to model distributions across continuous of outcome. Consider that there are real numbers. Real numbers just like not only 1, 2, 3, 4, etc. If I'm talking about 0.01, 1, 0.02, etc., it means we are talking about the complete possible real numbers. So here, for example, the uniform distribution puts equal weight on all numbers between 0 and 1. Okay, so here there can be multiple numbers between 0 and 1, and each one is having the equal weightage. So because there are infinitely many numbers between 0 and 1, so this means that weight it assigns to individual points must be necessarily be 0. Okay, so if consider we are talking about the weights, then when it comes to the infinity, 1 by infinity, if I divide, so here 0 to 1 is there. If in between, if infinity points are there, each one will have equal weightage, then 1 by infinity, I will get a 0 only. Okay, so nearest to the 0. So for this representation, so for this reason that we do not want to have weight to be have 0. We want a real weight for each of the points. And for this reason, we represent a continuous distribution with probability density function, which is also called as a PDF. Probability density function, it means that each point will have equal probability and density of this is uniform. So that, such that the probability of seeing a value in certain interval equals the integral of the density function over the interval. So here probability density function, it means that here we necessarily do not want weight to be 0. So for this purpose, we wanted to divide some between the intervals and equals the integral density function over the intervals. It means integral, it means that how we are representing the weight, or how we are representing the probability. For this purpose, we are using the integral density. Integral, that is, I cannot write density in terms of 1 by infinity. So we are talking in terms of integration, and all these will return to the 1. That is integration from 0 to 1. In this way, we are talking about the density. So density function for the uniform distribution is just, that is here written 1. So uniform, we wanted to have uniform distribution. Uniform distribution, if consider if x is greater than or equal to 0 and x is greater less than 0, then we return 1, else we return 0. Okay, so this is a uniform distribution. Uniform distribution, it means that I'm passing some x value. I'm checking whether this x value is greater than 0. If so, then we will return 1. So probability that a random variable following that distribution is between 0.2 and 0.3 is 1 by 10. Here we that is between 0.1, 0.2 and 0.3 is 1 by 10. So there is a function called random functions within the Python. So which will generate the random variables uniform with uniform density. Okay. So pseudo, it means that by default it means temporary or imaginary value we are passing. So this is a probability density function. The next, cumulative distribution function. Cumulative, it means that here we are going for the summation. Okay, summation, it means that the previous one will be added with the next one, which gives the probability that random variable is less than or equal to certain value. Okay, so here we are talking about um, uniform random. So cumulative distribution, it means that here we are go on adding with the values. So returns the probability that uniform random variable is greater than, less than or equal to x. So if x is less than 0, then we are returning 0. Else if x is less than 1, we return x. Okay. Here we want the distribution between 0 and 3. And else, if consider x is neither less than 0, neither less than 1, then we return 1. So uniform random is always less than 1. So this is a graph. So here you might be thinking what it represents. So here this function. So when we talk about the uniform distribution, when it comes to the discrete value is only have the points. That is, for 1, I'm having specific value. For 2, I will have a specific value. But when it comes to the uniform distribution, it means that there is a continuous line between, that is connection between the points. And this is regarding cumulative. Cumulative, it means that I wanted to perform the summation. So here at 0, I'm having a 0. Then I go on adding the values for 1. And later, when it comes to the cumulative, that it reached to the 1, it remained the same for each value. So let us see this function. So here, uniform distribution, uniform probability density function, if consider x is greater than or equal to 0, it returns 1. That is, it is there. And if x is less than 1, it returns 0. But when it comes to the CDF, so I wanted to check for x which is less than 0.4. Okay, consider I wanted to check uniform CDF. So let us talk with the graph. So consider that I am checking value for the 0.5. Okay, at 0.5, I wanted to check the value, how much it is there. Then I pass the value for the function. So returns the probability that uniform random variable is less than or equal to x. Okay, if consider x is less than 0, it will return the 0. Okay, so consider I passed -1 +1, or sorry, if I pass -1, then I will get 0. If consider else if x is less than 1, if x is less than 1, it will return x only. If I am passing 0.5, so this will give me x, that is 0.5 only. And if consider x is else, that is the case remaining is x is greater than 1 or equal to 1. In that case, it returns 1. Then for the 0.5, it matches with the second case, that is x is less than 1, and because of which this will return zero point 0.5, and zero point 0.5 will be plotted here. Then when it comes to the 2 or 1.5, etc. So at 1.5, again I will have the third case, that is else, written 1 will be there. So I will have 1 only. So this is cumulative and probability density function. Okay, you might be thinking why we need to go for these concepts in the data science. So here, whenever we are defining a relation between the two attributes, then we need to represent the relation graphically. And when we represent the relation graphically, then graph gives us the complete analysis by connecting all the points. If consider these are discrete points, then it might be unable to give the complete clear definition. But when it comes to continuous distribution, this will show how my values are giving, or whether it is increasing or decreasing, etc. And that's why uniform distribution is also a way of showing the probability distribution or probability. Okay, and probability values will always lie between 0 and 1, and because of which these values never cross 1 and always remain between 0 to 1 as well. Please take a look at this contents. Okay, now. Okay, now. So let us start with the normal distribution. So normal distribution, it means that here, whenever we are talking about the continuous distribution, this is a continuous range, but values are in terms of curves in case of normal distribution. Okay, so It is a classic bell curve shaped distribution and is completely determined by two parameters. Its mean, that is represented by mu, and its standard deviation represented by a sigma. Okay, it means that on the x-axis I will have mu, and on the y-axis I will have sigma value. The mean indicates where the bell is centered, and the standard deviation how wide it is. Okay, so it has distribution function. So this is always a represented function. So it is giving in terms of exponentially, that is f of x for the mu and sigma equal to 1 by under root 2 pi sigma, and exponential to that minus x minus mu x square, sorry, x minus mu square and divided by 2 sigma square. Okay, so it means we will have x and y, and mean is represented by the center, and wide standard deviation always give how wide the curve is. So this is a function, or we can say the inbuilt definition, or I can say the code for drawing these figures. Okay, let me check whether I can show you the implementation. So here, consider that I wanted to go for calculating the square root for that is whatever this formula is there. For this purpose, the function is there. That is normal PDF. And a range is taken in the below function, and it has called for the implementation. So this is how this will show the various PDFs, that is whenever after changing mu and sigma values. So mu equal to 0 and sigma equal to 1. That is here, whenever I'm saying that this is a 0, this mu value is 0 and sigma value is 1. So sigma value 1, it means that this will show me the how wide it is. So the next, the dotted green line for sigma 2, then mu 0 and sigma 5.0. So this will show you how wide it is, that is the longest. And whenever mu equal to -1, then how the sigma value will also change. So let me check whether I can show the implementation. Students, still there are 10 minutes for the class. So please uh, do not put the attendance. I will take attendance by myself. Sorry, I forgot to unmute myself. So let us start with the explanation. So here, this is the formula for the normal distribution. Okay, so distribution function, that is 1 divided by square root of 2 pi sigma, then exponential square of x minus mu divided by 2 sigma square. Okay, so let me show you the function. So initially, this is taking the square root 2 pi, that is 2 pi square. So this will go for the math by 2 plus a square root of that. So then here we implemented the same function, whatever we are going for this, that is 1 divided by and then exponential. So after this function, we called x from range from 10, that is minus 50 to 50. And based on that, we implemented the function. So I will go for just implementing the function. So this is the way probability distribution is shown. So for each of these cases, it has shown me the graph. So these are the different normal PDFs, that is normal distribution, density distributions. So the time being you can study. So please don't leave the meet. I will take the attendance and then you can leave. For 2 minutes, bear with me. Or else you all can enter your roll numbers into the chat window, because this will take around 5 to 10 minutes to write down the number by myself. And next lecturer may not wait for so long. So please, all of you, write your roll numbers into the chat window